everybody. Thanks, Daniel. So I'll tell you about my story, and I'll emphasize on kind of my personal view of different stages of my story. Hopefully, that'll be useful in your own journeys. My relationship with students started when I started my PhD at Imperial College London. When I was choosing a topic to do my PhD in and a place to do it, I was quite interested in the interplay between electronics and physics. In a way, the connection between computing and science. And what attracted me to Imperial College was the fact that the research group there, the high energy physics research group, was quite involved in building instruments for high energy physics. And I had the wonderful privilege to work on projects to upgrade the triggering and data acquisition system of the CMS experiment at the LHC. What the triggering and data acquisition systems is responsible for is, first of all, when we collect information from collisions. So when we have a collision, particles release signals within detectors. These then are processed by electronics and then fed into a data acquisitioning system that pulls them out of the detector. And what we do is we try to reconstruct very quickly the event to get an idea of whether a given event is interesting. And once and that process of reconstructing the event is the basis for what we call triggering, which is this decision that we take about whether to keep a given event or discard it. And if you know much about quantum mechanics, you would know that a lot of the events at the LHC are not necessarily very interesting from a physics perspective. So triggering is this essential activity that allows us to collect high volumes of data while maximizing the usefulness of it, if you will. And it was a very interesting problem, because for me at least, because it's a high performance computing problem where you have to make decisions very quickly. You're very constrained in terms of time and resources. The equipment that we use for that is not conventional general purpose computers, but very often is specialized electronics, often using FPGA chips to perform the actual computations. And during my project, I worked on, there was two stages. The first one was commissioning an upgrade to the level 1 trigger of CMS that was already built and was being installed at the time when I joined. And during that time, I worked on activities that helped us make sense of whether the detector was the system was working as expected. It was absolutely wonderful to get to point 5, see how CMS was built in general, but also how different systems would work. And then after I finished that project, I moved on to a project to come up with a new version of the upgraded trigger. And for that, I developed low latency machine learning algorithms for primary vertex reconstructions. And so that's the place where I got in touch with machine learning, and it was absolutely an absolutely wonderful experience. But what really stuck with me was this question of, okay, you have your algorithm, but then you have these huge systems that actually need to feed it with information. And the interesting question of what do you do to make sure that those systems work as expected has stayed with me. After I graduated, I had an opportunity to join an early stage startup to help them with their technology problems, where I was exposed to leadership. I was managing a small team of engineers, about 20 people or so. I did that for a while, but then I realized, that's around the time of COVID and the pandemic, and I realized that I needed to maybe go to a bigger company, be surrounded by more people. And in 2023, I joined Skyscanner as an engineering manager. And in Skyscanner, I lead a team of platform engineers. So what we do in Skyscanner is, my team is to build the systems that actually host machine learning models and allow users of Skyscanner to use machine learning models to plan their journeys. And the places where we use machine learning in Skyscanner largely falls into kind of two broad categories. The first one is sorting and relevance. So if you go and search for a flight between two destinations, Skyscanner would return a lot of results, but not all of them will be equally useful to you. And so one technique that we employ is to use machine learning algorithms to rank these based on preferences. So the algorithms look at where you're based, and if you have any history with the company, we can determine your preferences. In addition to that, we also develop internal machine learning models for internal optimization of the retrieval. As you can imagine, travel is a highly combinatorial problem where there's many ways to travel between 2 points, and that can get computationally expensive, and we use machine learning to help with some of that, make it more efficient. So please let me know if you're interested in operations, machine learning operations in particular. And it's great to chat to you all today.